In this example, we're going to calculate the volume of a solid using the shell method, in which we have an axis that is a vertical axis, but it is not the y-axis. So for this example, we're going to take the equations y equals x squared, x equals 2, and y equals 0, and we're going to take that area and we're going to revolve it about the line x equals 2. So let's start by labeling our axis of revolution, which is here at x equals 2. And next we'll go ahead and sketch the bounded area. So we need the equation y equals x squared. We've got the equation x equals 2, so our axis is also a boundary, and y equals 0, the x-axis. So here we have our bounded region, and we're going to revolve this about the line x equals 2. Okay, so there's our solid that we're looking at. Okay, next let's look at a cross-section for our volume. And we're using the shell method. So when I sketch in one of the cylindrical shells, again, I'm going to shade this rectangular strip to help us decide on the setup of our problem. Okay, now we're looking at a cross-section of one shell within our volume. Okay, so we need to identify if this is a dx or a dy problem. We need to know what the radius of our cylindrical shell is, and we need to know what the height of our shell is. Okay, so you always want to start with identifying if it's a dx or a dy problem. So we look at our original shaded area and we take a look at our rectangular strip, and we can see that that is measuring a length along the x-axis. So that's going to mean that this is going to be a dx problem. Next, we need to identify what the radius of each of our shells is. So here would be our radius. And then we need to identify what the height of our shell is. And remember, the radius is always the independent variable, and height will depend on the radius. Okay, so for this problem, our radius is going to be the length from the axis out to the outer edge of our shell, which will be out to the outer edge of our solid. So when we go to measure that, we have to measure from the bigger value, which is on the right, to the smaller value, which is on the left. So when we go to measure that in terms of x, we are just going to take 2 minus whatever value of x we are plugging into our equation. Next, we need to know what the height of our cylinder is. And for our height, we are measuring from the top down to the bottom, which means we need a y top minus y bottom. Okay, so our function for height will be in terms of x. Our y top function was the parabola, x squared, minus our y bottom function was just the x-axis, so y equals 0. So that tells us our height function is going to be x squared. Okay, now we're going to take these shells and we're going to accumulate them. So we need to take an integral of these. And remember, our formula for these shells is we need 2 pi times the radius. Our radius here was 2 minus x, times the height of each shell was x squared, times the thickness of each shell, which was dx. And we're accumulating those, so we're taking an integral, and we are accumulating them over the variable x, which means our limits will go from 0 up to 2. Okay, so there's your setup. You'll distribute, you'll integrate, and when you solve this out, you should get 8/3 pi.